Welcome to the deep dive. Today we're digging into how humanity first harnessed metal. Think copper, think silver. It wasn't easy. They faced huge hurdles, intense heat, getting the stuff pure, and then, actually shaping it precisely. We're exploring that whole technical journey.
And the timeline is just, well, it's kind of staggering when you look at it. We're not just talking Bronze Age. No, this goes back maybe 10,000 years. We've got evidence, like actual copper beads from northern Iraq, that old. Moving from stone to metal. It wasn't just a step, it was a giant leap. Instantly changed things.
Okay, so let's tackle that first big problem you mentioned, heat. Copper ore needs, what, over 1,000 degrees Celsius to melt? And copper itself is pretty soft naturally. How do they even start to manage that kind of fire consistently?
Well, the very early attempts, maybe 5,000, 6,000 BCE, places like Sumeria, they used simple pit furnaces. But those could really only handle the easy stuff, the oxide ores.
Right, okay, so not the more complex materials.
Exactly. The real breakthrough, that was the shaft furnace.
Yeah.
Ingenious design, really. It used something called reverse heating. Basically, the hot gases rising up would preheat the fresh ore coming in.
Ah, like recycling the heat within the furnace itself.
Precisely. And that stabilized the internal temperature way up high, maybe 1,200, 1,300 degrees Celsius. Suddenly, they could reliably process much trickier sulfide ores, like chalcopyrite. Big deal.
Okay, furnace mastered, step one. But you still end up with this pool of molten copper, which, as you said, is soft, not great for a tool or a weapon. So how did they solve the durability issue?
Alloying, that was the key. Bronze. They figured out that adding tin, sometimes just 15%, made the copper much harder.
Right, the classic bronze alloy.
Yeah, but here's the kicker, the maybe unexpected bonus.
Yeah.
Adding that tin actually lowered the melting point. It went from, 1083 degrees for pure copper down to around 960 Celsius.
Wait, so adding something made it easier to melt? That seems counterintuitive.
It does, but it was huge. It meant casting larger objects, more complex shapes, became much more controllable, more feasible on a bigger scale. It wasn't just about hardness. It was a manufacturing win.
Interesting. Okay, so temperature control leads us to the next challenge, purity. Silver often comes mixed with lead, right? How'd they separate that?
Right, different problem, different brilliant solution. This one goes back pretty far too, maybe 4,000 BCE in Anatolia. It's called cupellation. It's basically chemical refining. Silver melts at 962 Celsius, lead way lower, like 328. So they'd melt the mix and then blow air over it.
Blow air, what does that do?
The oxygen in the air reacts strongly with the lead, but not so much the silver. It forms lead oxide. Some sources call it Mitsudaso. This lead oxide separates, kind of turns into dross or gets absorbed by the hearth material, leaving behind really pure silver. Clever stuff.
Wow. Okay, so they've got pure metals, they can melt them reliably, but how do you get from a puddle of liquid metal to, say, intricate jewelry or detailed statues?
Early molds were simple, right? Yeah, early molds were just carved stone or clay, pretty basic shapes. For the really complex stuff, the game changer was the lost wax method.
Ah, I've heard of that. Explain how that works.
Okay, so you start by sculpting your detailed model out of beeswax. Exactly what you want the final piece to look like. Then you carefully coat that wax model in layers of fine clay, letting it harden.
So you have a clay shell around the wax.
Right. Then you heat the whole thing up. The wax melts and runs out through small channels you leave.
Leaving a perfect hollow cavity inside the clay mold.
Exactly. A perfect negative impression of your original wax sculpture, capturing all the fine details. Then you pour your molten metal into that cavity. Once it cools, you break away the clay mold. This technique, especially well developed in China by the spring and autumn period, was essential for those incredibly detailed ritual vessels and complex shapes.
And once they had that kind of control heat, purity, shaping the impact on society must have been enormous. Let's talk warfare first. Bronze weapons.
Oh, absolutely. Changed everything. And it wasn't just having bronze, it was about the right bronze. In China, for instance, sources show they used a specific ratio for long weapons, like spears or the gadget dagger axe. It was about 8 parts copper to 1 part tin.
So around 12% tin. Why that specific mix?
That ratio gave an optimal balance of hardness and resilience. It meant the weapon was hard enough to be effective, but not so brittle. It would shatter on impact. Huge tactical advantage.
Makes sense. And beyond the battlefield, these metals completely reshaped economies, didn't they? Moving away from barter.
Yeah, a total revolution. Think about Mesopotamia around 3000 BCE. They started using silver, weighed silver, as a standard medium of exchange.
So the first real currency.
Pretty much. Its standardized value made trade much easier over distances. Later on, you get things like the Athenian tetradrachm, those silver coins from the 6th century BCE. That became one of the first truly widespread, trusted coins because people knew it was consistently pure silver. It built economic trust across borders.
And it seems different cultures really focused on different uses, too.
Definitely. You see a contrast. In the Mediterranean and Europe, the focus was maybe more on tools and weapons initially. Whereas in China, while weapons were vital, there was also this incredible development of a ritual vessel culture. Huge, elaborate bronze dings and cauldrons weren't just functional. They were symbols of power, status, connection to ancestors. Very different emphasis.
Fascinating divergence.
So looking back, copper and silver weren't just materials they found, they were catalysts. They forced ancient peoples to become really early chemical engineers and thermal scientists,
Yeah.
mastering heat, understanding chemical reactions like oxidation and alloying. These are fundamental technical skills, and honestly, they laid the groundwork for so much modern technology.
It's incredible how these ancient solutions echo today. I mean, think about copper. We still use it constantly, partly for its antibacterial properties, right? In hospitals, on surfaces, even in coins. So here's a thought to leave you with. What ancient technical solution, maybe thousands of years old, are you interacting with or benefiting from right now without even realizing its deep historical roots? We'll see you next time on The Deep Dive.